In this lecture, we're going to see how we can set up our operator plus as a non-member function of our point class. And again, what we want to do is something like this. It is going to be exactly the same thing we did in the last lecture, but the implementation that makes this work behind the scenes is going to change a little bit. So what we really want is to add up 2 points. And what we're going to be doing behind the scenes is what we see here. It's not going to be a member function of any point object. It's going to be a freestanding global function that we call and pass our parameters. So we're going to say operator plus. This is going to be a freestanding function. And then the left operand is going to be specified as a first parameter here. And the right operand is going to be specified as a second parameter. This is what we're going to do. And the signature is going to look like this. This is not going to be a member function. Again, I really have to make this super clear. We're going to specify the return type as we did before. We're going to say operator. We're going to say the name for the operator. And then we're going to be specifying our parameters. The first parameter is going to be the left operand. The second parameter is going to be the second operand. And we're going to do whatever we need to do for this operator to work as we want in our C++ program. So let's see how this is exactly going to work for our point class. Okay, so here is our point class. We have our 2 member variables, mx and my, as you see down here. And if you look down here, you're going to see that we have our operator plus function. We have the implementation, and it is done in line because we want this to live in a header file, and we make it in line to tell the compiler that this is going to be constrained to a single translation unit. And if we include this from multiple files, we are not going to violate the one definition rule. If you want, you could put this implementation in a CPP file, and that's going to be your decision. I am just using this setup here to show you how we can do this. Okay, so we're going to specify the return type, which is going to be a point. And then we're going to say the name of the operator. It is what we have seen before. We say operator, we say the name for the operator. In this case, it is the plus operator. And then we're going to specify the left operand as the first parameter and the right operand as the second parameter here. And this is the setup we use. Now, this operator function is going to need to access the private parts of our point class. And remember, again, this is not a member function. This is a freestanding function that is living in the global scope of this file here. So it doesn't really have direct access to the private parts of our point class here. To give it access, we're going to declare it as a friend function of our class, and we're going to use this declaration we have on top here. We're going to say that it is a friend of our class, and this is going to give it direct access to the member variables. For example, this is going to let it directly access mx and my, as you see here, from our point parameters, and this is going to make our operator much cleaner. Okay, so once we have this set up, the compiler is going to know to come and use this operator to add up 2 point objects. And the syntax here is going to work as we have seen in the last lecture. The compiler is going to pick up the operator we just set up as a non-member function, and it is going to use that to add up our point objects. And again, when it says you do P1 plus P2 as we have here, it is going to transform the syntax to what we have here. And it is going to say operator plus. It's going to use the first operand as the first parameter. It's going to use the second operand as the second parameter here. And this is going to work. Now that you have an idea about this, we're going to head over to Visual Studio Code and play with this a little more. Okay, so here we are in our working folder. The current project is addition operator as a non-member. This is what we're going to do here. And I think we can just use the code from the last lecture. So we're going to grab the VS Code folder. We're going to grab our point files and the main CPP file. We're going to copy those. And we're going to be using those as our starting point here. We don't want to set up the point class again. So now that we have this, we're going to open this little guy in Visual Studio Code, and we're going to have our code. The first thing we're going to do is to take out the operators that we did in the last lecture. We don't want to be using this here. And we're going to head over to the CPP file and remove this as well. We want this not to use the setup for member function operators. We want to use freestanding global functions as our operators. And for this, we're going to just go down and really put this in place. We're going to implement this as inline first here. So what we're going to do is say inline, and the return value is going to be a point type. We're going to say operator plus, and we're going to specify our two parameters. The first one is going to be a const point passed by reference. We're going to call this left to mean that it is a left operand. And the second one is going to be a const point passed by reference, and we're going to call this right. Now, what we want to do in the body of this function is really to return a point object, and we're going to be using the member variables of left and right, adding them up and setting up the member variables of this point object that we want to return here. So we want to say left and say mx, and we want to add that to right mx. We want to use the syntax like this. You see that we get squiggly lines, and the reason is this is a freestanding global function. It's not a member function, so it's not going to have direct access to the member variables because it doesn't really have access to the this pointer. Let's finish this up and show you that this is going to give us a compiler error if we try to even run this or build this. We're going to say left and say my, and we're going to add this to right my. This is what we would do to really set this up. But as I have said before, this is not going to work because this freestanding global function doesn't really have access to the private member variables here. If I changed this to be public, for example, this would work. You're going to see that if we try to build this program, it is going to build. You see that the errors have gone away. And if we try and build this program with GCC, again, what we have in the main CPP file is code to just include our point class and set up a few point objects and add them up. If we try and run this program, you're going to see that it is going to work exactly as we expect. Let's bring up a terminal window, and it is going to be using PowerShell behind the scenes. We're going to clear and run Rooster. You're going to see that this is what we expect. Our operator is going to work, but the design is really bad because we have just exposed the implementation details of our point class. What we really want is to flag this as private because they are private to our class. But this is going to bring up a problem because now our operator plus, which is implemented as a freestanding global function, is not going to have access to our private member variables because it's not a member. One solution we have to this is to flag this as a friend function. And for this to work, we have to just grab the header for our function here. We're going to copy that, and we're going to set this up as a friend to our point class here. We're going to say friend, and we're going to put in the header for our function. And this is going to give it direct access to the member variables of our point class. And you're going to see that this is going to work. If we build our program here, it is going to just work fine. You're going to see that the build is good here. We can clear. Let's clear properly and run Rooster. This is going to give us what we expect. Our operator is going to work. And this is really the best of both worlds. Our member variables are private, and we don't have to expose the implementation details to the outside, because if we make our member variables public, this is going to be really bad. Anybody would come in and use them, and that's bad design. We want our member variables to be only accessible through the getters and setters that we provide if we need them in our program here. And this is really all we set up to do in this lecture, showing you how you can set up an operator plus, or in general, a binary operator as a non-member function. We have just set up this as an inline function because we want this to live in our header file. But if you want, you could also do this as an implementation function living in the CPP file. And all you have to do to make that work, we're going to copy this, put this in our CPP file. We're going to do that. We're going to paste this in here. And we're just going to remove the inline keyword. And the compiler is going to look for the implementation and it's going to find that in our .cpp file here. And this is going to just work fine. We're going to build this and show you that this is going to work as well. Let's go in the header file and make sure that this is commented out. It is commented out. This is just fine. We're going to build with GCC. And you're going to see that the build is going to be good. And if we clear and run Rooster, we're going to see that we have what we expect here. And this is really cool. One thing you should make sure of is that you don't have both implementations in. If you leave the one in the header file in, now we're going to have two definitions for the operator plus, and the compiler is going to be confused. You're going to get a compiler error. So make sure that you just have one of these in, and it is going to be fine. And if we go down here, we're going to see that we have the operator plus redefined multiple times. One definition is in the header file, the other is in our .cpp file, and the linker is going to be confused as to which is going to choose, and you're going to get this error here, so don't do this. I am going to take out what I have in the CPP file because I favor to use the inlining feature in modern C++. So that's what I'm going to use here. But note that both of these are going to work. You're going to choose whatever works better for your particular situation. And before we wrap up this lecture, I really want to drive the point home that this is really going to call the global function we have set up here. This is not going to call the member function. What this is going to do behind the scene is really to say operator plus, and it's going to use P1 as the first parameter, and it's going to use P2 as the second parameter in this case here. In fact, if we take out the setup we do here and use the exact same thing that the compiler is going to do behind the scene, this is going to work. Let's do this. We're going to say point and we're going to say 0.3, and we're going to add them up behind the scenes. We're going to say operator plus. Because this is a function that is available to us, we can really use this. We're going to say operator plus, and then we're going to use P1 as our first parameter and P2 as our second parameter, and this is going to work just fine. Let's build our program. We're going to use GCC to do that, and now we see that we have a problem. What did we do wrong here? We didn't put a semicolon at the end. I think this is our problem. Let's build again. We're going to use GCC, and now the problem is going to go away. If we clear and run Rooster, we're going to see that we have what we expected. So in this case, the compiler is looking for a candidate function to carry out what we want to do here, and this is the operation to add up 2-point objects. It is going to find our function here, which is this function, which is a global freestanding function, and it is going to use it. And behind the scenes, the compiler is really going to do what we are doing on line 10 here, and this is going to work. This is really all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to show you how you can overload the subscript operator on your point class. And we're going to be using that to manipulate our mx and my member variables here, and that's going to be really cool. So go ahead and finish up here and meet me there.